what I am going to talk about are the future pitfalls and promises of safety and autonomous systems. So in the last presentation, you heard a lot about artificial intelligence and really language analysis, text, speech, and everything that was said before applies to what I'm going to talk about today. But I'm going to spend a little bit more time looking at the computer vision aspects of artificial intelligence. Same algorithms, same approaches, same flaws, just a different application. But as you heard, I was once a fighter pilot and I flew A-4s and F-18s for the United States Navy. I have landed aircraft on aircraft carriers, and indeed it was this experience where I learned that automation was there in the aircraft carrier setting. Planes always land better by themselves than when humans land them. But there were problems and people were dying for reasons that had to do with some vague, ambiguous software problems. And so even in the 1990s, when I was flying these aircraft, I recognized then that there was a problem in designing machines that had humans in them, and how we were designing the interfaces, the man-machine interface was becoming a problem. That inspired me to go back to school. I got my Ph.D. at the University of Virginia. I was at MIT for 10 years, teaching there. I became a mom, moved that set of operations down to Duke University, where I've been very happy as a mother. My lab is the Humans and Autonomy Lab. There's a joke in that name. You have to be a certain age to get the joke. So you can ask an old person if you don't get the joke behind the name of my lab. So I would say if I have one guiding principle to my lab, it's this idea of skills, rule, knowledge, expertise. And it's a framework to help you think about when should you automate a task, how should you automate a task, and where do you need to make sure that you have the human. So on the lower left side of the screen, what you see is a cockpit. And indeed, when I was a pilot, I spent 2 years in flight school really to learn how to keep the plane in balanced flight, right? We spend a lot of time training so that flying and keeping the aircraft stable is second nature. So we're learning to automate our skills in flying. And once you actually learn it's highly automatic for you to fly, then you spare cognitive resources in your head to then approximate something we call rule-based reasoning. And so you can think about this as procedures, maybe kind of a cookbook way to life. So for example, in this case, if there's a high engine temperature, there's a set of procedures. You don't commit them to memory because you don't want to make a mistake. You kind of look them up in the book and deal with them to make sure that you maintain as safe a flight as possible. Now, once you understand how and when to apply rules to different situations, then you can spare up other cognitive resources to start dealing with uncertainty in the world. And indeed, that's why you see that arrow getting bigger, because uncertainty is low, especially in flying. You know, you've got all the information from the sensors and the gauges and the computer screens, and it's pretty clear, if you're highly trained, what the state of the aircraft is. But sometimes bad weather will roll in, for example, and weather can introduce a lot of uncertainty because you don't know what's about to happen, especially if you're on instruments. So then you have to approximate something we call judgment under uncertainty. You have to start making some guesses. You don't have perfect information about the world. You think the weather might be better in this one area, so you're going to change your heading and go that way. Sometimes that's right, sometimes that's wrong. And then you have to deal with the outcomes. Once you've had to deal with some uncertainty, then when you get to expert-based reasoning, that's when you deal with maximum uncertainty. And the example I like to give is the miracle on the Hudson. This is when Chesley Sullenberger had the dual engine flameout because of bird strikes in both engines and had to figure out where to land his Airbus aircraft. It wasn't clear whether he could make a runway, so he chose to maximize his certainty, even in a highly uncertain world, and put it down in the water. His training helped him, but he was making a guess, a big guess, as to whether or not he could do that. Fortunately, his guess was right, and he was able to pull this off. But indeed, it's not clear, at least under the automation that we have today, we aren't able to automate this. And so we don't have any automation, much less artificial autonomy, artificial intelligence in the form of autonomy to do this. So understanding that if you look down at the skills section of the arrow, that is where computers reign supreme. If the sensor data is correct and the world can be sensed to build something we call the world model, then computers do really well at skill-based reasoning, pretty good at rule-based reasoning, assuming that they can get the information about the world. But then as you start to transition up that curve, the knowledge and expert-based reasoning, computers just aren't there right now. We can't do it. I don't care how much artificial intelligence you think you can apply to this problem. There is no AI right now that can approximate knowledge and expert-based reasoning. And the reason for that is that the reasoning under uncertainty is actually, it's the kryptonite to AI. And we're going to talk about, so that kryptonite can actually show up in unexpected ways in the skill and rule-based reasoning. And that is indeed what we really have to think about when we're talking about applying AI in safety critical systems like driving, flying, medical systems. So we're going to give some examples. But in developing my thinking about this, I've come up with a recipe, because I get asked this all the time. Like, how do I know when I develop an unsafe system? I do a lot of consulting, so sometimes driverless car companies will want to talk to me, sometimes aviation companies, and even medical companies. And so what do I think about when I think about whether or not whatever the system that they're proposing is correct? So I go through, basically, I've developed this recipe so that you know how to figure out whether or not you have an unsafe autonomous system. And an autonomous system is one that embeds any kind of probabilistic reasoning. So your Netflix recommendations or Amazon recommendations, that's an autonomous system, but it's not safety critical. So I would actually say this is really more safety critical autonomy systems. So the first checkbox is inappropriate role allocation. That means that whoever's designed the system cannot or has not figured out the correct way to allocate humans to one role. Where's everybody on that curve? Have I given the skill and rule-based reasoning to the automation? Have I given the knowledge and expert-based reasoning to the human? Or did I implement this correctly? And I'm going to show you a set of examples. You heard in the last talk how important testing was. Believe me, this is the #1 problem that we have in real-world implementation of these systems. Companies are not testing them adequately. Testing is probably, I think, the most abused area in artificial intelligence right now. It's abused because it's just generally not done, at least to the levels that it needs to be done. Often you'll see people make mistakes because of a perceived financial imperative. We'll talk about that. Generally, this also happens with a lack of regulatory oversight. I'm not a huge fan of regulation. I would prefer to see companies self-regulate, but when there's a financial imperative, that kind of counters the ability to apply self-regulation. And then last but not least, we'll talk about seasoning with hubris and hype, which is all the rage right now in Silicon Valley. So let's look at the first case study. I like to bring up the Boeing 737 MAX. This is one that everyone knows, 2 different aircraft on 2 different occasions. There was a struggle in the cockpit. There was some underlying automation that the pilots didn't know about. And there was a fight between the pilot and the control system of the aircraft in these 2 episodes. Both planes crashed and lots of people died. But what a lot of people don't know is there had been some other of similar struggles where pilots were fighting with the automation. And indeed, pilots reported this back to Boeing. And so Boeing knew that there were problems, and then of course, that's why they paid a lot of money and were taken to task over this, because they didn't implement this correctly. And so let's talk more specifically about that. So what was the inappropriate role allocation? Well, there was a problem with this MCAS system where the MCAS was basically controlling the pitch of the nose, but it was hidden and the pilots were never briefed that it was there. So the pilots thought they were actually controlling the nose position of the aircraft. And indeed, there was some hidden automation in there, right? So this is a problem with design. It's not a bad thing necessarily. There's a lot of automation. Most commercial aircraft, we did a study that you can read about on my website. Most pilots only touch the stick out of any flight for 3 minutes, out of any flight, whether the flight's 30 minutes or 30 hours, right? They're only touching the stick for 3 minutes. That's how much automation is in there. So it's the idea of putting automation in aircraft is not new, and it's certainly well established, except this was a new kind of software, a new kind of automation, and then it was in a place that people didn't know, pilots didn't know. So this is very bad, because if you're starting to put some control authority that you're giving to the automation and the pilots don't know about it, then they don't know how to turn it off, or they can't reason through what the problem is and maybe how to potentially successfully control the aircraft when something goes wrong. There was a lack of internal organized testing strategy. Companies who are under financial pressure cut corners, and that is all companies in all settings, in all domains. So, you know, they spend a lot of time and money on production of a thing or a product, but then they want to just do, most companies just want to do the minimal testing. I'm not saying all companies do, but it is definitely human nature, corporate human nature, for companies to skimp on the testing so that they can get the product. And indeed, this is a huge problem in Silicon Valley, where we want to make everything 80% good enough, and then we're going to roll out our cell phone software and let consumers complain, and then that's when we make changes. When we get X enough complaints, that's okay for your cell phone, which is not safety critical, but as we'll talk about for cars, it's not good for Tesla to do this, because indeed they've got a safety critical system that could kill both the driver and other people on the road. A little foreshadowing. So in this case, Boeing wasn't doing enough testing. And there was a perceived financial imperative. So there's a long history at Boeing. Boeing used to be run by engineers. And then, you know, I would say about 15, 20 years ago, there was a change where Boeing, people with MBAs started taking over management at Boeing, and then engineers were basically put into some kind of second tier. And then there was the chasing of the stock price. So I do have friends who work in Boeing, and indeed, they told me right before the 737 MAX, it was a corporate culture to basically constantly check the stock price, because that was the measure of how well people were doing, is driving that stock price up. Well, it turns out, you know, being overly fixated on the stock price and not being fixated on listening to those safety reports that other pilots were giving about problems with the 737 MAX, that's an issue. There's a lack of regulatory oversight in this particular case, because Boeing tried to claim that the 737 MAX is the same plane as the Boeing 737. And because it's the same plane, the old certification for the 737 should apply for the 737 MAX. And the FAA regulators were like, sure, that sounds good to us. They didn't do any checking at all. And it turns out the 737 MAX is a completely different aircraft, different wings, different engines, different control system. In no way, shape, or form should the regulatory agencies accepted this as a new version of the 737. Boeing just named it the 737 MAX to make it easier for them to get it certified. And indeed, it worked, except that, of course, people had to die for that. Now, there's some hubris and hype in there. You know, Boeing is really trying to push the market. And then, of course, nobody at that time could foresee what would happen with COVID. And how that really decimated the aviation market. But I think all of these factors kind of rolled in together have really demonstrated how, we would consider the automation on the 737 MAX to be baby autonomy, only tiny bits of AI, if you could even call it that. It's really more rule-based AI than anything else. And so if we could have these many problems with what we would call baby autonomy, what's going to happen when we start to see AI put in other areas? So the second case study I want to tell you about is the battle that's been going on in the rail industry. So I like to use these different industries so you can appreciate the scope of the battles that are going on. In this particular case, it's not that we have too much automation, it's that we don't have enough. So there has been a battle going on for some time, whether or not there should be 2 people inside the cab of a train, the engineer and the conductor. So I've been doing rail research for a long time, and I'm here to tell you that there's not enough for both of them to do there, and there's marginally enough for even one person to do. And the problem when you put 2 people into a cockpit of any vehicle and they're bored, and this is a diagram that I've got, there's some research that we've done in the past about boredom. What happens is if you're in a low task loading, means you don't have a lot to do, or a monotonous environment, one of 3 things is going to happen to you. You're either going to have an attention lapse, meaning you're distracted, you're going to get tired, and or you're going to get bored. And indeed, all of these things can happen. And the problem with boredom is, much like attention lapse, if you're bored, the brain seeks stimulation and wants something to do. And indeed, I've helped out on some accidents in trains where, not surprisingly, trains derailed, crashed, had problems because of cell phones, iPads. People are very bored, they're frustrated, and it's painful for the human brain to be bored. And so if we know that boredom and distraction is a huge problem in rail, then we need to think about, maybe automation would be a good thing. And indeed, the United States is a third world nation when it comes to rail. There are many, many other countries with substantially less GDPs than we have that have far more advanced rail systems, including a lot more automation. And why is it that some countries are so much further ahead and they have automated trains and they've realized that, there's not a lot of uncertainty about trains. That uncertainty graph is low. Trains they're one way, they're on one track. There's no lateral movement unless there's a problem. And in general, we see derailments when humans make mistakes. So indeed, this is inappropriate role allocation, because now we're forcing people to do a task that's extremely boring. It's causing them for sure to be distracted and to maybe be engaging in events in tasks that are going to be antithetical to what they should be doing. And there is no organized testing strategy. This is a huge problem with the Federal Railroad Administration, indeed in rail in this country. There's a huge problem with introduction of new technologies. At one point, the Federal Railroad Administration tried to mandate positive train control, and it took, I think only recently have companies actually started to meet congressional mandates, because these automated positive train control technologies actually will stop the train before there's a collision. So it is a way to stop accidents happening because of our inappropriate role allocation. So we're not investing in the right technology. Well, we are slowly now, but it's only mandated partially. It's not mandated on every train, on every rail, everywhere in the United States. And we absolutely need to do that, because without doing that, we can't ever get to these fully autonomous trains. So there's a huge lack of regulatory oversight. The perceived financial imperative, and this is why it's highlighted as perceived. It's perceived because the train companies, we're back at the robber barons of the turn of the century, where they just don't want to do the capital outlay that it takes to make this investment. And it's very short-sighted, because if they'll make this investment now, then they will eventually be able to go to more automated trains, which they can increase their throughput. Economies of scale would bring to bear here. And so this is a huge example of, sometimes a lot of automation is the right thing to do. And certainly this is the right domain to do it, but because of a financial imperative, lack of regulatory oversight on the other side of the spectrum, we see problems there. Okay, I'm just gonna skip that. Okay, last case study, Tesla Autopilot. So this is the driving domain, and I save this for last because this is the domain that everyone sees every day and is very familiar with. There is a huge problem with the introduction of Autopilot. I love Tesla as a company. I love the car. I wish that we could get rid of all dealerships everywhere like Tesla does, but there's a huge problem with their Autopilot system. It embeds, of all the systems we've talked about today, it embeds the most AI, and that is through the form of deep learning and the convolutional neural nets that are used to power the computer vision system to potentially see objects, obstacles, lanes, things that the car needs to do to navigate. The Autopilot system is extremely brittle. I'm not going to have time today to talk to you about all the testing that we've done. I would encourage you to go to my website if you want to read about real-world testing that we've done in real-world environments that demonstrate how brittle the Tesla Autopilot is. But you can see from these three pictures, these are old pictures. The red car is from 2019, person ran underneath a truck, killed the driver. This is a 2016 Joshua Brown Tesla that went underneath a semi broadside, also killed the driver. These are relatively, older accidents. In the past month, we've had 2 more of these events where the driver's not paying attention. They're distracted. Go back to that boredom diagram. They put the car on autopilot. It's not really an autopilot like you would think of in a plane, and trucks come across the driver, in front of the driver, and the car will ram. In the case of these 2 cars, and they hit at about 65, 70 miles an hour. You're not going to survive something like this. The bottom graph is out in Mountain View, California. Walter Wang, he was driving an Apple engineer on his way to work playing a video game and letting the car drive itself in the area that is probably the best well-mapped area in all of Silicon Valley. The car driving right into a barrier, again, at around 70 miles an hour, and he did not survive. So what we're seeing here is a huge problem with, and this is what I foreshadowed before, is that there's a problem here at the skill level. I mean, the car definitely can't do this, and the car's, not claiming to do this because it's an level 2 car, which means that the driver is always supposed to be engaged. But it appears to do the skill and rule-based control so well that it makes drivers complacent, and they think the car can do a better job driving itself between the white lines and making the right turns. But indeed, there's some hidden gotchas there. And I'm going to show you in a picture what those hidden gotchas are. But when we think about that inappropriate role allocation, we're putting drivers in a situation where they think that the car is more capable than it is, and they do not want to always have their hands on the steering wheel because they think the car is more capable than it is. And there have been many, many cases where this is a good example. It's a picture I got off of YouTube. On these Tesla forums, the drivers will pump each other up and tell them how to trick the system. And so this is the driver monitoring system. If you'll put an orange in the steering wheel, it'll actually produce enough counter torque to fool the system into thinking that your hands are on the steering wheel. There is a whole subculture of people that just they believe that the car is so capable that they feel like it's okay to put an orange, and in many cases get in the back seat of the car while it's driving itself. There was a mother recently who put her kid in the driver's seat, let him fall asleep. You can go look at that video too. While she's filming from the back, I mean, you have to, if there's a Darwin strategy coming out in self-driving cars and or driving assist cars, you're going to see it on YouTube. YouTube is the best research tool ever. But we see this, we see how people abuse it. And then the problem is that Tesla does not have an internal organized testing strategy. They do release the software, they let problems emerge, they're waiting for the public to cry foul enough. And there's a huge financial imperative. The stock price is really, I mean, if you haven't seen what's going on with the Tesla stock price, it's very interesting to watch. The stock is incredibly overinflated. Even Elon Musk says it's overinflated. So, and there's no regulatory oversight. The National Highway Traffic Safety Administration, under the previous administration, did nothing. All of these shearing off of the roof incidents that have happened in the last month, the National Highway Traffic Safety Administration is paying more attention, but it's not clear whether or not they're going to do anything about it. There's so much hubris and hype surrounding these technologies that I would say that this example of Tesla. I mean, it is the quintessential example, and it will go down in history as probably the worst instantiation of AI in the hands of the public of our time. And let me show you what's driving all of this. So this is a picture that the Toyota Research Institute gave me, a set of pictures to show me and everyone else the problems that they're having in their self-driving cars. And this is why Teslas are struggling. This is why Waymo's CEO, John Krafik, just quit. These problems we do not know how to solve. So let me show you what's happening. This is a self-driving car at an intersection in Cambridge, Massachusetts. When I show you this picture, you see a truck. It's just one truck, you see the truck. Now I'm going to click this button and I'm going to show you what the AI, the underlying AI sees. Wait a minute. The AI sees two trucks, a bus, a gigantic person, a fence, 4 poles, a traffic sign. Okay, let's go back. Let's go check it out. It's just a truck. But what the system is doing is it's doing low-level bottom-up reasoning, and it's parsing. And this is where there are problems with text. You know, the natural language processing that we saw before, it literally sees the numbers from the pixel level, but it can't, the AI cannot approximate knowledge and expert-based reasoning, and cannot apply inductive reasoning to say, this is a gestalt of one truck. It's one entity. It's not all of these different things. And indeed, this problem is why you will not get self-driving cars anytime in my professional lifetime. We cannot figure out how to fix this. We are very, very far from figuring out how to fix it. We are so far, and here's yet another example. So this is Mobileye, a computer vision company. They went out and tested a Tesla, and they figured out that this speed limit sign with a little bit of extra duct tape, electric tape on the 3 would make the Tesla see this as 85 miles an hour, and it would cause Teslas to automatically accelerate. This is something that falls under the title of adversarial machine learning, where you can passively modify the environment to trick autonomous systems into performing in ways you don't want them to perform. And so, you know, today's academic tricks are tomorrow's Russian hacking or even American hacking tools. And so we need to be very sensitive to the fact that autonomous systems that rely on computer vision, and indeed really any artificial intelligence, is incredibly brittle. And we've got to figure this out. We've got to figure out how to assess what is the right role allocation, how much testing, and what is the right level of testing. We have to try to understand and identify when companies, you know, we can identify when companies do have a perceived financial imperative, because that is really a good sign that that company is likely going to be taking shortcuts in developing or testing autonomy, which they shouldn't be doing. Lack of regulatory oversight. You know, I can't say enough about this. First of all, we need more regulatory oversight, but the problem is the federal government has just been decimated. I don't think the Department of Transportation, and I don't even think the Department of Defense, underline Department of Defense, knows how to test autonomous systems. I think this is a national security problem. It's also a huge economic problem. And we're just not producing enough people that understand how to, in an organized first principle manner, address the limitations of artificial intelligence and at least identify them so that we can mitigate it. We're not training anyone. This is a big beef that I have with the National Science Foundation. Most academics do not see the teaching of testing. How do we test? How do we certify? Teaching, safety, and certification are considered company issues and not academic issues, so they're not being taught in universities. So I think that's a huge problem that we need to address. I also think we need to try to, you know, throttle back the hubris and the hype, because I think if we can lower the hype temperature, then people will actually admit more the problems that are going on. There was a recent driverless trucking company, Starsky. The owner, he's like, I'm out. We're closing up shop. You can't do it. So on one hand, there was one autonomous trucking company that said, this is not possible. And he made a very public statement that this is not possible. On the other hand, Too Simple and Aurora are new companies that are trying to do an IPO or raise more funding, saying it is possible. And in my mind, I'm like, how's it possible? One company went bankrupt and said you can't do it. Two more companies are promising people they can do it. They can't do it. I just showed you the picture for why they can't do it. So we need to figure out how to try to even this out, because the more we inflate the hype, the more we're going to cause these problems.